Hello to Darkness344 here, and in today's video I'll be doing a tutorial on this vertical shift register design that I did a showcase of in the last video. So just a quick reminder, it's 2 wide tileable, so well technically 4 wide, but we have an output every 2 blocks for cells. So these 2 blocks is a cell, these 2 blocks are a cell, and these 2 blocks are a cell. So we can have quite a high density of memory. And of course, they're very fast as well. So what you first want to do is just block up like this, or find an area where you want it in, and we're going to be building the main part of the cell. So the way the cell works, I kind of explained it in the last video, is it's made of 2 parts. One part is the actual memory cell, which is this repeater, and we can use repeater locking like this to actually store a value. So for instance, we're storing a 0 right now, but if we input a 1 and toggle this, then we are storing a 1. Then the second part of the cell is a comparator, and this just lets us toggle the output. So for instance, if we put a repeater like this, and if the comparator is on subtract mode, we can toggle the output. So this is just the read part of the cell, and this is the actual storage part of the cell. So we're going to want to, first of all, actually we want some redstone blocks or even barrels filled with items, though I'd recommend redstone blocks. And we're going to place a comparator like this on subtract mode, then a repeater on 1 tick into the comparator like that. Then we're going to place 2 blocks like this, solid blocks, and we're going to have a comparator on subtract mode going into this one like this, and the same thing over here. So when we actually stack this, these redstone blocks, well, the next cell across will be stacked 1 higher, like this. So these redstone blocks would be here. So you can, if I put a comparator and a repeater down, you can see how this works. These comparators can be powered by these redstone blocks. So now that we've done this, we're going to place 2 blocks like this and repeaters like that, so we can actually power these comparators from the side. Then we're going to want to block like this, redstone dust, block up like this, and a repeater like this, and this will be our output. Then for our input, we're going to block up like this, redstone dust, block up again, and then we can have a repeater over here as our input. And the reason we do this is just to give us a bit of space so we can actually put the control logic in for these repeaters. So actually I think this is actually a repeater and then this is the dust, not the other way around. I made a mistake. So now if we get some glass or slabs, in Bedrock Edition you can use glass both ways, so you can either have your control circuitry at the bottom or the top, but if you're in Java Edition, since Redstone only travels one way up transparent blocks, you must have your control circuitry at the bottom of the cells. So then we can just block up like this and have redstone dust on top like that. So when we're actually stacking this, you actually want to block down like this and place a piece of redstone there, and that's because when we stack it, this redstone dust won't always be stacked because it's 1 block up. So you need to include this for stacking. Then we're going to do the same thing as we've done here on this side. So like this, and we'll actually go 1 down like this, and we have our redstone here. So for instance, we can power this, and as you can see, it goes into this comparator, and the same is for this side as well. So if we get rid of these, then we can actually stack this. And I'm going to show you it by hand first, then I'll show you it using world edit or command blocks, for instance. So to do this by hand, the next cell will just be 1 up. So for instance, if we get our redstone blocks out again, we can go like this, and all we have to do is build this exact same cell, just 1 block higher on this side. And as you can see, it's fairly simple to do, just like this. And all we're doing is building this one, but 1 higher. And then for the other side, we'd do the same thing, so just 1 higher on this side too. So for instance, these would be the comparators. And as you can see, it's just almost like a diagonal design, so it just alternating up and down. because after this, then the next cell you'd build would be just one lower, like this. And then you'd have your comparators like this, of course. So there we go, as you can see, it's the alternating up-down design. However, and just building a cell on top is fairly simple. All you have to do is have the redstone blocks from earlier, of course, and you can just build directly on top like this, follow the exact same pattern, like this, for instance. Then we have our repeater, which joins up to this, bridge, like that, on both sides. And of course we have a block across like this. And there we go. That's basically how we build a second cell. So these are our inputs and these are our outputs, and this is the write to the cell control logic, and this is the read from the cell control logic. So of course then we can place repeaters here. So for instance, let's actually just test this cell. So if I take out some lamps, we can input some numbers here, and if I place lamps here, we can get the outputs over here. Then of course we'll need some levers here and here for the control logic. So if I put in the number 1, 0 into it, I forgot to actually include the redstone blocks. We actually need to block up like this. So on your, make sure these are all on subtract mode, these comparators. So on your last cell in the row, these comparators won't actually have any blocks because you haven't stacked anything there. You will need to place redstone blocks or barrels with items in so they actually activate, or else they won't work. So there we go. So if we write the number 1, 0 into the memory, we can just do it like this. And as you can see, we have a 1 here, and if we just remove this, and we have a 0 here, then we can read it just by activating this line, just like that. We can write different numbers in. Say we want to write the number 01, we can write it, and then we can also read it. And of course, if we change what the data is, it will still save the data, of course, and we can read it as many times as we want. So now onto the actual stacking part. So for instance, if you have world edits or command blocks or even structure blocks, so as we see, we've built this so far, where we have these redstone blocks, of course, and we actually have these additional blocks underneath just to have the redstone, because if we actually select the blocks for stacking, so we're going to want to select from this corner to preferably this corner over here. So there we have the boundary box. I'm using a behavior pack by SI Silicon for the world edit. I'll try and include it in the description. So we select these like that, and we can break this block as well. As you can see, these glass blocks are not included in the selection, and these redstone blocks on top, because they're an actual block on top, see, they're not included either. So to actually include these redstone, we have to have a block below, so the piece of redstone dust can go on top like that. So now that we've got this to stack, we're gonna look in the direction we want it to stack, and we type stack like this with the semicolon, and then we can just hit enter if you just want one of them, or if we want multiple of them, you can type in the number of cells you want. So I want 8 cells, and then we -1 because we already have 1 cell built. So there we go, and that's 8 cells, just like that. So now we actually want to be able to stack it in this direction now, and the way we can do this is if we just select the bottom one again. So we still have this box selected, and we're going to select the top one over here like this. We're going to only stack it 1, and I'll show you why. So stack 1 like this, and now we have this, right? So, but you can see the problem, because these comparators, all of these cells are actually meant to be 1 down. However, what we can do is just move these cells up or down by 1. So if we just go to the bottom or the top and look in the direction we want to move, you can just type move and then 1. And there we go. So let's just remove this block as well. And that just shifts them up or down by 1 block. So now you can see these cells are actually getting the redstone blocks that they require. So there we go. Now if we select the whole thing now, so from this corner down here to this one up here, so we get the whole thing like this. Now we can say I want 8 cells, so this is one cell and this is another cell, so we have 2 cells here. So I want 8, we're going to type stack 3 because we already have 1 cell, or 2 cells even, and there we go, now we have 8 cells. So 1, 2, 3, 4, 5, 6, 7 and 8. So now I'm just going to type deselect to deselect the boundary box, and now it comes to now we have to actually hook up all the cells. So the way we're going to do this is kind of complex, but we can use glass blocks to do this to make it a bit simpler. So if we go across like this, right, with redstone, as you can see, when we do the next row, we're going to be cutting this line from going down here off. So what we can instead do is replace each block where we're going to be cutting with a glass block instead. Actually, that one's going to be fine. So like this. So now on the top one, when we have that line across, so like this, of course we're going to replace all these ones with glass blocks. It means the redstone can actually go down by 1 block. However, since there's a solid block on top, it can't go up to the next row. So it basically only allows one way. As you can see, it comes from this repeat over here and goes down to this row over here, but it can't go up to the next row. So instead of building all of this, we can of course stack it again, and we can just select this corner and this one over here, and we're just going to write stack 7, and there we go. So now that we have this, we're going to want to do the same thing for the inputs. So if I just go across like this with of course the glass blocks, we're basically building the exact same thing, just this side instead, just like this. Again, redstone across like that. And then we can of course select these again. I could have alternatively just copied it from this side, but this is just going to be easier. Stack 7. And there we go. So now if I deselect, we have inputs on one side, outputs on the other side, and we have our control logic. So I might have mentioned this earlier, but on Bedrock Edition, if we say power this line, it goes all the way down out through the solid blocks, and you can of course also power it this side as well, and it will travel upwards through this tower. However, on Java Edition it only works up, so if you're making control logic on Java, it will have to be at the bottom, but if you're on Bedrock you can of course make it at the top. I'm only going to make it at the top because it's just a bit simpler. So what you do for your control logic is you just you pretty much use a decoder, and so you'd input a binary address and you could decode it to whatever cell it is. For now I'm not going to bother with any of that because there's so many examples online and I'm sure it shouldn't be too hard to make. I'm just going to use solid blocks like this so I can actually power the cells from here. So if we just actually I want that block. So I'm just going to place a solid block wherever these redstone are. I might need to add some dust back in like this. Oops, redstone. And then I'm going to add levers like this. So this is our write control for each cell. So this, say you take cell 0 for instance, this lever will allow cell 0 to write. Oh, and just one more thing to add to the cells to make them fully work. On this cell where the comparators are like this direction, you also need to add redstone blocks like this, or else the comparators won't get powered and the cell will not function. So if you want, if you didn't have them powered, it just wouldn't work properly. It just, as you can see, it'll just, if we say power this bus, it doesn't matter what the control logic does, it will just output whatever's on the bus, and that's just a bit annoying. We don't want that to happen, so we must add these redstone blocks. And that's the same for all these top ones, because they don't actually have redstone blocks. We have to add redstone blocks on these as well, like that, so these repeaters lock. So now that we've done this, I'm just going to add these levers for the right as well. So let me just add like this. Oops. And once I've done this, then we can actually test the memory cells. So let's add some inputs as well. So 1, 2, 4, 8, 16, 32, 64, and 128. And then of course we'll add some levers as well. So since this is the inputs, if you want to add repeaters, say you have a lot of cells, make sure to do it in between the two cells, or if you do it say here, this cell won't get powered, so you have to do it in between like this. So preferably one block before a glass block or one block after one of the glass blocks, and then it should work fine. And the same thing goes on the other side for the right. So we're just going to take lamps like this, and these will be our actual data out. So let's just put some random data in. For the first cell, we're just going to put a random number in like this. So we'll save that to this cell, then let's change the number to something else, and we'll save that to the next cell, then let's just change it again, and we'll save that to the next cell. I'm not going to try all the cells, but you can. And then of course we can get the data out just like this. As you can see, it was the data we put in. And of course you can get the data out as many times as you want and in any order. So yeah, that's these cells. They're very fast, and they have quite a fairly decent density. If you want more dense, you can of course use comparator cells with barrels and items and stuff. But for just random access memory, this is fairly fast and fairly compact as well. But yeah, I hope you like this tutorial. Please like and subscribe, and I'm out.